So currently we are in an R studio. In an R studio, we have set our working directory. And in our working directory, you can see one file, frogs_weights.csv. In this file, we have a data set of the 40 frogs weight, and we want to perform a z-test on it. Now, the first step is to load our data set. To load the data set, let's create a variable named sample data. And after typing the name of the variable, let's give the operator sign in R. After giving operator sign, now we will write down one function to load the CSV file, and name of that function is read.csv. After typing the read.csv, we will give the parentheses, and within the parentheses, we will type the comma inverted comma. And after typing the comma inverted comma, we will write down the name of the file that is holding our data. As we have told you earlier, that the name of the file is frog_weights.csv. So we will type that file name here. After typing the file name, we will come out of the parentheses, and then we will hit the run button or press the Ctrl-Enter key. As we will hit the run button or press the Ctrl-Enter key, then you can see it here in the environment tab that our data is loaded. There are the 40 observations in the 2 variables. And we hope so that you will have a good idea that the 40 observation means that the 40 rows, and the 2 variable means that the 2 columns. Let's check the architecture of our dataset. To check the architecture of our dataset, we are going to use a function str. And after typing the str, we will write down the name of the variable that is holding our data. And the name of the variable is sample_data. After writing the name of the variable, we will come out of the parentheses, and we will hit the run button or press the Ctrl-Enter key. Once we will do that, then look at the console. In the console, you can see that there are the 2 columns. The one is going to be the frog's ID, while the second one is going to be the weights_grams. The both are the numeric variables. Great. Now, as we have told you earlier that the z-test is only applicable when you are going to have the normal distribution. So this is pretty important to check the distribution of our dataset in which we are interested. To check the normal distribution of our dataset, we are going to build the histogram. And to build the histogram, we are going to use the R-based function HIST. After typing the HIST, we will give the parentheses, and we will write down the name of the variable that is holding our data, which is sample data. So we will write down the sample data, and after typing the sample data, we will give the $sign and select the column name or the variable name in which we are interested. Right now, we are interested in a weight. So we will select the weight_gram variable. After selecting this, we will come out of the parentheses, and we will hit the run button or press the Ctrl-Enter key. Once you will hit the run button or press the Ctrl-Enter key, then in a plot section, you will have the distribution of your data in form of a histogram. By looking at this histogram, we can say that our data is going to have the normal distribution. And if our data is going to have a normal distribution and the total number of the observations or the values are more than 30, then it means that we can apply the z-test. Now keeping in mind the previous video. In a previous video, we have told you about the population standard deviation and the population mean as well. So this is time to use that population mean and the population standard deviation to calculate the z-statistics. So let's do it. To calculate the z-statistics, we are going to create a variable named test. After typing the test, we will give the equality sign in R, and after typing this, we will type the z.test. Do you remember that we have told you earlier that the z.test is basically a function that will calculate the z-statistics for us. After typing the z.test, we will come into the parentheses, and within the parentheses, we will type the x, and then we will define our sample data. As we told you earlier that we are interested in the weight grams of the frogs. And that's why we will type the sample data. That is actually the name of the variable that is holding our data. Then we will give the $sign, and we will select the variable in which we are interested. So we are right now interested in the weights_gram variable. After this, we will give a comma, and we will type the mu. And after typing the mu, we will give the sign of equality. Now what will be the mu? The mu is going to be the population mean. And do you remember the population mean in the last video? Yes, the population mean was 50. Now after defining the population mean, now this is time to define the population standard deviation. To define the population standard deviation, we will type sigma dot x. And after giving a sign of equality, we are going to write down the standard deviation of our population. Do you remember the standard deviation of the population in our previous video? It was 5. After typing the 5, we will give the comma. And after giving a comma, we will type alternative. Now after typing the alternative, we will give a sign of equality. And now we are going to define that what we want to have. We want to have a one-tailed test or the two-tailed test. Currently, we are interested in a two-tailed test as we have defined earlier in our previous video. So what we will do, we will give the comma inverted comma, and within a comma inverted comma, we will write down two dot sided. After typing the two dot sided, we will come out of the parenthesis. Now our R code is complete. Let's run it. To run it, let's hit the Control Enter. Once you will do that, then look at the console. Do you find any error? No. It means that our test statistics has been successfully calculated. Now let's print out the values of our Z statistics. To print out the values, we will type the print and then we will give the parenthesis, and within the parenthesis, we will type the name of the variable that is holding our test statistics. And then the name of the variable is test. After this, we will come out of the parenthesis and we will hit the run button or press the Control Enter key. As you will do that, then look at the console. In the console, you are going to have the outcome of your test statistics. Now this is time to interpret our results. If you look at it here, that we are going to have a Z value of 6.20 along with the P value of 5.403 multiplied by 10 raised to the power minus 10. If you look at it here, then you will find it out that this test has been carried out at the 95% confidence interval. Now you know it very well that at 95% confidence interval, the value of the alpha is going to be 0.05. Now please tell us that our calculated p-value is smaller than our alpha value or not. Yes, indeed, our calculated p-value is very small than our set alpha value. Now what you will do in this case? We have explained it to you earlier that if our calculated p-value is smaller than our set alpha value, then in this case, we will reject the null hypothesis and we will go for the alternative hypothesis. We hope so that this interpretation will be clear to you now. And now you will be quite comfortable to perform the one sample Z test by yourself in R. Please stay with us. In the next video tutorial, now we will talk about the t-test in lot of details.